If you're interested, it's just purely voluntary.
Yeah, but I'm 9 to 5, both Friday and Saturday.
Both Saturday and Friday and Saturday? 9 to 5? And you want to access office hours?
Yeah.
Where do you work? What town?
Sacramento.
Oh.
And South Sacramento.
Oh.
Well, it's like, I don't know, just throwing it in.
I wouldn't mind. I know my wife would. Yeah, it's really hard for me to work around that.
I know. I wanted to talk to you after class.
Okay, we'll talk. You guys, or how about this then? I'll make a decision. I think it benefits you more if you're interested in doing this, do it on Saturday morning.
Okay.
To give you an extra day to get some homework done, maybe find out where you're struggling. So what do you say, 10 o'clock on Saturday? You get to sleep in a little bit? 10 o'clock if you're interested. You don't have to come. We have to do it in public, so if all came, it would be probably a problem anyways. So 10 o'clock? Shoot. I'm not coming very prepared.
Is that three-dimensional plane, or?
No, it's just 2 minutes. It's just 2 minutes.
Are you not at Sierra College for office hours, or?
I can't. The building's, the place is completely shut down.
Okay.
Is that okay?
Yeah.
Is it okay to just do like at Starbucks?
Yeah, that's fine.
Shoot, is anybody gonna help me? Anybody recognize this area?
Mhm.
Fairway, thank you, Fairway. And right in here, there's a big theater.
Oh, then you told me.
Oh, excuse me, thank you, my goodness. And there's a big theater here. It's a pretty big parking lot. There's a Starbucks in here. How about Starbucks? Inside or out, just look around. And
that-
10 o'clock.
Is that like towards Lincoln on Highway
Yes.
65?
So
Okay.
Highway 65 starts here. It's not on the sign.
Oh, okay.
It only goes north from Highway 80.
Okay.
It's the third exit up. Is that all right?
Okay. Yeah, that's fine.
If you get lost, you can do this. I better get this right. You can use that if you get lost. So I have it with me. So you guys, you want to give it a shot? If I'm going to use Simpson's rule with 4 subdivisions for this function, it simply means I'm going to do this. Use my nifty little formula. I suppose it simply tells me that I've got my delta x over, gosh, how did that go?
3.
3 times my function evaluated at the first subinterval times what coefficient? 1. Or just don't put anything, that's fine. It's understood to be 1. Plus my function f evaluated at the second subdivision, however,
4.
second subdivision, second tick, excuse me, times what coefficient?
4. 2. No.
No, it's the last tick. That being the case, the coefficient's just
1.
positive 1. Are you guys there?
Yep.
And in this particular example, delta x is simply nothing more than the whole interval, I should say, the length of the whole interval divided by 4, which is how many subdivisions I have. And so I think my delta x over 3 is going to be my pi over 8. Did you say 8? Well, delta x is going to be pi over 8, but if I divide by 3, I get pi over 24. Of course, my function evaluated x of naught is simply going to be f evaluated 0 plus 4 times f evaluated a quarter way from 0 to pi quarter. So that's a quarter way from 0 to pi halves. Plus 2 times f evaluated pi over. You guys, am I doing okay with my arithmetic? Be honest. Plus 4 times f evaluated 3 pi eighths. And finally, plus 1 times f evaluated, good, 4 pi over 8, or excuse me, pi over 2, same thing. Of course, I'm dealing with the sine function, and I'm running out of room. Since I'm dealing with a sine function, I guess that gives me pi over 24 times, let's see, the sine of 0 is 0. plus the sine of pi 8, excuse me, I misspoke. I meant 4 times the sine of pi 8. What's the sine of pi 8? What's the sine of pi 8? Anybody in this room? Not one person in this room.
Square root 2 over 4.
The square root of 1 minus the cosine of pi quarters? All over 2? You guys, it's okay? Using the half angle identity for the sine function?
Can you show us how you got that?
Yeah, I can do that. How about this? I think the sine of twice some angle theta could be interpreted as nothing more than plus or minus the square root of 1 minus the cosine of an angle theta. All over 2. You've been using this all summer long, haven't you? You just wrote it differently. You squared both sides. Isn't that just my half angle identity? Oh, sorry, I wrote it backwards. My goodness. I meant this. Doesn't that tell me this? I'm serious, you guys. Haven't you been using this all over the place in chapter 7? Using integrals or guided integrals?
I don't see where you got the sine theta over 2 squared.
From here to here, I just squared both sides. I got a better idea. Don't look at anything on the board. Do you guys agree with this? Jeepers. Let me turn this off. Do you agree with this? Just be honest. So you guys are feeling comfortable with that? All right, let me be lazy. Let me do it for the cosine function. Here too, I want some honesty. All right, if you're happy, then let me just change the name of the variable y. Let me call it x. And if I call that x, doesn't that give me the cosine of x plus x? Which is this. But that would give me, well, replacing this y with an x, that would give me cosine squared of x minus, here too, replacing that y with an x. Isn't that sine of x times itself twice? Now, using my Pythagorean identity, or one of my Pythagorean identities, can't I merely dive in and interpret the cosine squared of x as 1 minus sine squared of x? But if this is 1 minus sine squared of x, and I combine it with this last term, doesn't that give me this? Well, more correctly, this. Now, if I came in and isolated the sine squared of x, I subtract 1 from both sides. Multiply both sides by negative 1. Then divide both sides by 2. I think it tells me sine squared of x is nothing more than 1 minus the cosine of 2x all over 2. If I make a substitution, replace x with, I don't know, how about theta halves? It's going to tell me this. If I take the square root of both sides, shoot, it's exactly what I have over here. It's just a simple derivation from your basic addition angle identities for the sine and cosine function, isn't it?
How does pi 8 that?
Well, to compute the sine of pi 8s, which by the way is half of pi quarters, so theta's pi quarters. So I think, David, check this out. When I look at, if I can write this properly, sorry, you said pi 8s. Isn't the sine of pi 8s the sine of 1/2 of, well, an angle with which I'm familiar? And so I think that's going to give me plus or minus the square root of 1 minus the cosine of pi quarters all over 2. Oh, but shoot, you guys, pi is living in the first quadrant. Sine of anything I live in the first quadrant is positive. I made my decision. It's just that the cosine of pi quarters, like I said, is a number with which I'm familiar. Oh, there it is. I put it in. And if you're okay with this, that plus 2 times, I've lost my function. Sine or cosine? I forgot. Is it sine? I just closed the quiz out. So the sine of pi quarters is just this. And don't yell at me, but plus 4 times the sine of 3 pi quarters is the sine of half of. Did I say that wrong? I'm sorry. I meant to say. Did I erase it? Sorry, you guys. I'll come back. I meant to say the sine of 3 pi eighths is the same as the sine of 1/2 of 3 pi quarters, whose sine is, or cosine is, root 2 over 2 again. Let me just get the same darn term over here. And lastly, plus my function f, which is a sine function divided by, oh, that's easy. Half is positive 1.
Don't you know the 3 out in front of the 4? 3/8?
Well, careful. I think the sine of 3 pi eighths is sine of 1/2 of 3 pi quarters. I just maintained the cosine of 3 pi quarters. Oh, sorry, I used a sine function, not the cosine. The cosine of 3 pi quarters does have a sign change, doesn't it? So I think that's what changes. My apologies. Come on, you guys help me. Is that okay? If I were to simplify, I guess, I don't know, you guys, there's not much else I can do. I mean, maybe pull out a root 2 and cancel with the root 2 up there. It doesn't do much good. I think maybe here I can clean up. Okay, how about the next question? Because I turned the screen off, does anybody remember? Was it just finding the error?
Yeah. Exacting something else.
I can't without taking a break and finding the k value. So let's take a break. The first derivative of sine is, don't do it. Because I think through 4 differentiation processes, it brings me back to sine of that. Piece of cake. So I think the 4th derivative as a function in x is simply this function. And if I'm restricting my attention to the interval from 0 to pi half, shoot, and you're deep, deep REM sleep, what does the graph of that equation look like over the interval from 0 to 2 pi? 0 to pi, 4 halves, not 2 pi speed. Increase of 0 up to 1. Done. So I think this 4th derivative function is bounded above by positive 1 over this particular interval. You guys, seriously, isn't that a piece of cake? Now I'll finally answer the question. The question was, let's come up with an exact value for this error approximation. So the error in using Simpson's rule with n subdivisions, at least in absolute values, is bounded above. Jeepers, you guys probably know this down by now, don't you? K times b minus a to the fifth. Actually, you don't have to have it down, do you? I put it on the quiz, didn't I? I think. I hope. 180 n to the 4th. So in my particular case, and using Simpson's rule with, 4 subdivisions, I'm bounded above by my k value, times my b minus a, raised to the 5th power, all over my 180 times, I've lost it, was it 4? Raised to the 4th power. Or shall I say, this is merely pi to the 5th, all over 180 times, I don't know, what is that going to give me? 4 to the, how about 2? You guys make me do all this work. The 13. All right, I'll stop. That's good enough. And now just approximate that. Cheapers, you guys. Don't
So
do
if we
that
actually
bad.
multiplied 180 by 2 to the 13th, you don't really care.
I'm too lazy.
But, you know, it's still an exact, right?
Yeah. Good, that's fine. By the way, does anybody come up with this value? Does anybody know what it was?
Yeah, it was like,
0.0002.
Ooh.
3 zeros.
Yeah.
I don't think so.
7 or 5 times 10 negative.
Negative 10 to the negative 4.
So that's
Good, something like that. Oh, come on. You guys, look at that number. What's going on?
It's 0.0002
But you're not jumping.
away.
What is this telling you?
That the approximation is pretty good.
The approximation using Simpson's rule is really good. Only using 4 subdivision. We're accurate by no less than that amount, by no more than that amount, excuse me. This is an upper bound for the error. That's a really small number for just using 4 subdivisions. That's just using 2 parabolas to match that graph and compute the error. I think that's pretty darn good.
Did we have to write that on the quiz?
No, I was just hoping you'd be jumping in your chair, and I could see that. I'll write it down on my great sheet.
So the book says that the 4th derivative of
Does he really? Oh, I've always written as less than 3 equal to. Either way, you've got it up and down.
You could still use one even though k would not, k would then be greater than 1 if it's going by the formula include.
But,
Could you, so do you have to use 1 or can you use anything greater than 1?
oh, I'm so sorry, you're asking a different question. You're talking about the actual k value.
Yeah.
Technically speaking, you could use something else, but if you just made a number up out of thin air, I don't have confidence that you knew where that came from. But you're right, you could have chosen anything. And if a strict inequality has to hold, then certainly this for 3 is going to hold as well, where equality is included. Anybody else in the quiz? Yikes. So you guys, let me see where I'm at. I should have done this while you're taking the quiz.